Okay, no, so we're done with this. So the next slide shows that basically how we can evaluate the efficiency. Now for to evaluate efficiency, we will be looking into this load line characteristics of the class B amplifier. Okay, uh, remember that this is an AC load line. Remember I can also draw this DC load line. So DC load line, typically it is like vertically at this point, which is Q. So this is just a DC load line, right? Okay, because okay, this is something constant, or we say there is no DC at the base actually. So the DC load line should actually intersect the Q point, and it is, and the property is such that it is vertically, okay, vertically above this Q point, this point. Okay, anyhow, the important thing is the AC load line to analyze. Okay, and for that we can see okay, we say that we should first recap the properties. We say that it conducts for the class B amplifier, conducts for only one half of the input signal, and there is no input biasing, so you cannot see any biasing at the base. So biasing, there is no input biasing. Okay, and okay, if this is the case, so there should not be any IB base current over here in this amplifier. It should be 0. Okay, and when and when there is no input signal, so again IC is equal to 0. IC is also equal to, so if there is no IBZ, there is no IB, so definitely there is no IC, so IC would also be equal to 0. Now our main concern is to find efficiency, to evaluate the efficiency of class B amplifier. So in order to evaluate this, we need to look into its this load line characteristics of class B amplifier. So it would be handy, or we can get good help from this load line. Okay, so the ratio is, efficiency is the ratio of the output power to the input power. So this is the AC output power, this is the DC input power. Okay, now for the first term, for this output power, okay, now for a sinusoidal signal over here, let's suppose over here, okay, if you have sinusoidal signal, okay, so we always go and we always take the RMS values. Okay, so I would say power is a combination of what, V times, so basically if I write over here, power is equal to what, is equal to your voltage times current. Okay, this is the basic definition of power. Okay, now if it is a sinusoidal, so I can replace this with an RMS value. Okay, I can replace this with RMS value, so with RMS value. Okay, and similarly I can replace this I with its RMS value for a sinusoidal signals. Okay, for a sinusoidal, like for a sinusoidal signal over here. Okay, now since we see that the class B amplifier only, okay, the sinusoidal is only the half cycle, one half cycle. Okay, as seen over here, this is only half cycle. Okay, so it means that I can, if I take this pi, so I can should divide it by 2, because okay, this is not a full cycle. So that's why I say this is RMS into IRMS divided by 2, representing the fact that this is class B operation for a specific 1/2 cycle. Okay, now if I convert this, so again I can write this RMS value. Okay, this RMS, sorry, this I can use, okay, RMS is equal to, it will be, it is actually what it is actually, I can rewrite this as V max. Okay, the max divided by 2, sorry, this thing. Okay, so it means that if I convert this into VC max, okay, the RMS voltage is VC, the maximum value. If I Okay, so the maximum will be VCE. This is the maximum. Okay, this is over here, and then I can say RMS. So IC max, IC max is somewhere over here. Okay, according to the definition. Similarly, IRMS will be IMX. Okay, IC max, and again, so I can write this as IMX. Okay, and basically, okay, IMX, and again I would have what? I would have this 2. Okay, and then okay, this 2 was, okay, this 2 was this. I can remove this. I can call this as what? P not AC. Okay, this is AC. P naught, this is the output power, this one. Okay, so if I calculate, okay, so this comes out to be V max, okay, into I max and divided by 4. Okay, because this and this I can get 2 from here and then 2, so I can see divided by 4. So this comes out to be 4, okay, in the denominator. Done. Okay, so okay, so output power, AC output power is explained, is done. Now what about the input power? Okay, so I can remove this all. Okay, the input power, which is the DC, so how much input power is drawn, okay, for the VC from the VC supply, which is VCC. So it will be equal to, okay, by definition this Pin is equal to, okay, this is equal to how much? It will be VCC, okay, times IC, okay, IC, okay, but I put Q because only, okay, we take that current which is operating current, and Q point is your operating point. So this Q point is also, we write this as a Q point, okay, ICQ. So it means that, okay, over here now if I put the values, remember, so if you see okay, now ICQ, now there is no, okay, if you see IC at the Q point, okay, what is the value of this IC? Okay, so if you see, this is basically 0, so theoretically, okay, this is equal to 0, so we can say, okay, this is, okay, 0. But whenever this signal is applied, okay, when the signal is applied, so basically there will be a conduction whenever it overcomes the 0.7. so basically you can see the value of IC, okay, has, okay, there is some conduction, okay, this one, there is some conduction. So we can, so how we can quantify this? So instead of, so we say, okay, instead of this IQ, okay, I would replace this term by I's average, okay, okay. So by average I mean that it will give me a good solution actually, that what is the average conduction for the current in the class B amplifier. So over here if you see average, okay, now we are taking average value, okay, to basically quantify the current for this half cycle. Okay, now mathematically, okay, I average can be defined as what? Okay, this is mathematical, if you know from your calculus, okay, the current, okay, its waveform, okay, and what happens that it's integrated, okay, this is, okay, the division by 2 pi, and the conduction over the conduction, if you see, this is the conduction integration from 0 to pi. Okay, I can also write, okay, over here if you see, I can write this as plus 1 by 2 pi, 1 by 2 pi, okay, this is, I can write this is 1 by 2 pi, okay, and for the next half cycle, which is from pi to 2 pi, okay, this will be but a value of 0, because there is no conduction for the other half cycle. So okay, so what happens that, Okay, for one half cycle, okay, from 0 to 2, from 0 to pi, for this half cycle, okay, I want to calculate the average value in this, okay, in this current, okay, waveform. So if I integrate this, okay, this integration of sine is minus cosine, it goes from 0 to pi, you put the value, okay, this will become 2 because cos of pi is minus 1, minus 1 times minus 1 is 1, and this is the value of the average. Okay, now we need to put this value over here right away in this equation, right?